In this video, we are going to be covering the oxidation of carbonyl compounds. Now, we have looked at oxidation reactions before when it comes to our alcohol, so let's just recap what reagents we need in order to carry out an oxidation. So when we do the oxidation, we have to have an oxidizing agent, which we notate using an O in square brackets. And the oxidizing agent that we use is potassium dichromate and sulfuric acid. So you can also write this out as acidified potassium dichromate. And depending on the alcohol that you have, you can form different products by changing the conditions. So you can have either of these two conditions. You can have reflux, or you can have distillation conditions. If the oxidation does occur, you will also observe a colour change. So the observation that you will observe, potassium dichromate is an orange colour. And once the potassium dichromate itself is reduced, it actually gives a green colour. So the observation that you should see if the oxidation does occur is a colour change from orange to green. Right, so let's just recap what happens with our alcohols when we carry out their oxidation. So this depends on what type of alcohol that you have. So let's start off with a primary alcohol. If you have a primary alcohol and you carry out its oxidation using the oxidizing agent under distillation conditions, the product that you get is an aldehyde. So it's the corresponding aldehyde to the alcohol. If you carry out the reaction under reflux conditions, you're actually going to make the corresponding carboxylic acid. Like that. Right, the other type of alcohol that you can carry out oxidation reactions on are secondary alcohols. And using the oxidizing agent under reflux conditions, you will make the corresponding ketone to that alcohol. Okay, and if we have a tertiary alcohol, regardless of what conditions we use, we cannot oxidize a tertiary alcohol. Okay, so they're the reactions that we have covered back in year 1. Let's now have a look at another conversion. So that's the conversion of an aldehyde going to a carboxylic acid. So we can start off with a primary alcohol and go to a carboxylic acid, or we can do an oxidation going from our aldehyde to our carboxylic acid. So let's have a look at this conversion here in a little bit more detail. So the aldehyde that I'm going to choose, let's just go for ethanol, like so. And if I carry out the oxidation, so when I'm writing the equation, I use O in square brackets as part of my equation. The O is, again, just potassium dichromate with sulfuric acid. That is, so this has to be done under reflux conditions. And that is going to form the corresponding carboxylic acid. So if this over here is ethanol, the carboxylic acid that it's going to produce is going to be ethanoic acid, like so. Now, there is no water molecule produced in this reaction, but what you do have to do is just double check that it is balanced. And if you just check over here, you've got 2 carbons here, 2 carbons there, 1, 2, 3, 4 hydrogens here, 1, 2, 3, 4 hydrogens here, and you've got 2 oxygens over here. So that is a balanced equation there. Okay, so again, just remember the observation that you will observe with this. It should go from an orange to a green colour. So that's the observation. Okay, so aldehydes can be oxidized to their corresponding carboxylic acid using an oxidizing agent and reflux conditions. Right, let's now have a look at ketones. So if we have a ketone, which is our other carbonyl, so we looked at aldehydes, now look at ketones, so I'm just going to go for propanone. And if I use the same conditions here, so potassium dichromate and sulfuric acid, and reflux it, this reaction will not occur. Okay, so ketones cannot be further oxidized to any compound using the oxidizing conditions. Okay, so this propanone would not react with the oxidizing agent, and therefore, in terms of observations, this solution should stay a orange color. Okay, so two things to remember: aldehydes can be oxidized to their corresponding carboxylic acid. Ketones cannot be further oxidized.